here's a question. How a paddle wheel spins at a point in a fluid flowing in a plane region. We're going to use the Green's theorem and come up with some ideas. Sometimes we refer to this as circulation density of a vector field. The k component of curl help us to calculate the circulation density of a vector field. So wherever you see circulation density of a vector field, it refers to k components of curl. So let's see what the idea behind it. As usual, suppose you have a vector field. It has two components, scalar components. Is a velocity field. We're going to go back to our rectangle as we did before. Consider your rectangle with a point X and Y in one corner. And as usual, since these two are parallel to x-axis, y-axis, you're going to have delta x, delta y as the sides. We can label the rest of the corners based on the information that we just presented. X plus delta x and y. On this corner, you're going to have x and y plus delta y. And here you have x plus delta x and y plus delta y. The counterclockwise circulation of F around the boundary of this region is the sum of flow rates along the sides. Let us do the computation. We're going to find the rates of flow along the sides. For the top, we're going to have f of x and y plus delta y dot negative I delta x, which gives us minus m of x and y plus delta y times delta x. For the bottom, what do we have? We have f of x and y dot I delta x, which is m of x and y delta x. For the right side, we have f of x plus delta x, comma y dot j delta y, which gives us n of x plus delta x and y delta y. And finally, for the left side, we have f of x and y dot negative j delta y, which gives us negative n of x and y delta y. Okay, so let us add the opposite side and see what do we have. For the top and bottom, we have negative m of x and y plus delta y delta x plus m of x and y delta x. If you factor out the negative sign, you have minus partial derivative of m with respect to y delta x. And then, so this is top and bottom, then right and left. If you add them together, you're going to have n of x plus delta x and y minus n of x and y which is going to give you the partial derivative of n with respect to x delta y. Adding these two together gives us the following. The partial derivative of n with respect to x delta y minus the partial derivative of m with respect to y delta y. This is nothing but the circulation around the rectangle. So obviously, if we divide the circulation around the rectangle by delta x, delta y, we're going to get our k component of the curve or circulation density. So circulation around the rectangle divided by delta x, delta y gives us the partial derivative of n with respect to x minus partial derivative of m with respect to y. And we call this the k component of the curve or circulation density. This guy is represented by curl of f dot k, partial derivative of n with respect to x, minus partial derivative of n with respect to y. Circulation density.